video, we solved for the motion of a simple pendulum and we found theta and theta dot as a function of time. In this video, I want to create an animation of this motion. So now that I have theta and theta dot as a function of time, I'm gonna find x and y, the coordinates of the pendulum as a function of time. These are gonna be just from the dynamics. Really, you don't need to know that right now. If you don't know how I got these equations, you learn that throughout the course. But basically, I know that the x coordinate is gonna be equal to the length of the pendulum times sine the angle theta, and I'm gonna use np dot sine numpy, and then the y coordinate of the pendulum is gonna be equal to minus L times np dot cosine theta. You learn these projections throughout the course. Okay, great. Where L is the length of the pendulum, apologies, that's a lowercase l, that's what I previously defined here. So L is in meters, it's the length of the pendulum. Pendulum cord in meters, and G is the gravitational acceleration in SI units. Okay, great. So I have x and y. Let me just plot the initial frame of this motion. So setting up the figure and the axes. So I'll be honest, I used some help online. I do not memorize these commands. So I've used some help online to set up the figure, but I'll write the code and we'll try to understand it together. Set up the figure and axis. So I'm creating a figure object in Python using the matplotlib plt.subplots function. Subplots. Okay, great. And let me see, do I need to use any commands? Yes, I'll need to use this import this package that will help me enable me to save and create an animation. Okay, so I have created the figure object and I will set the limits of my axes. So that's basically the max and min x values, and then I'll do that same thing for the y values. So for now, I'll set it equal to minus 2 times the length, 2 times the length of the pendulum, again small l. Okay, and for the y limits, that's minus 2 times l, 2 times l. Okay, we'll adjust these. So here I'm creating the first one. I'm creating figure and axes objects. Then I'm putting the limits of x-axis and the limits of the y-axis. Okay, that's great. And then I wanna create a line connecting basically the origin and the mass, the pendulum of the mass, and this line is gonna represent the chord. So creating or drawing a line from the origin to the mass m. This line represents the chord of the pendulum. Okay, for this I'll write line is equal to ax dot plot. So I'm gonna connect 2 points. So first I'll write the x coordinates of these 2 points, and then I'll write the y coordinates of these 2 points. So initially for the origin, x is 0 and y is 0. And then for the first location of the pendulum, that's at x, its x coordinates is at x0 and its y coordinate is at y0. Okay, very well. So right now I'll start by animating the chord, and then we'll add the circle representing the pendulum mass later on. Let's just start with the chord. Okay, great. So then I have the chord here, and I can probably plot and show, and let me double check that it's I'll be able to see the chord. So running. Okay, is there? Okay, no, that's not it. Not it, not it, not it. Okay, yes, this is the plot.show. So I have my first end of the chord is at the origin, and the second end is at the initial location of the pendulum. Okay, great. So now let me animate this to make this line move throughout the motion. I'm gonna create a function that's called update. So that's the update function for animation, and def update frame. So frame is the frame number. So for each frame, I'm gonna update line. It's no longer gonna be at its initial location. It's gonna be at the basically the new look x and y's at a certain frame. And I will return line. Okay, cool. Line with the comma, that has to do with Python syntax. Okay, and then I will create the animation. Okay, animation is equal, so I named my animation Annie, and that's animation dot function or func animation. So this is a function in the matplotlib.animation library. Okay, so what do I input here? I'll input the figure that carries the animation. I input the function that updates the figure, and the frames, the number of frames. So the frame basically here goes from 0 to the number of frames. So I'll let the number of frames be basically the size of this T array, the size of the solution.t or the solution.theta or theta. They all have the same size. So that's gonna be np.size, say x. And then interval is basically the kind of time interval between every frame. So I'll put that as 50 milliseconds and put is equal to 2. I think what this does, and we can double check, is that it makes an efficient solution. Just updating the objects that are changing. Okay, cool. And I can also save this animation. So any.save, saving my animation object, and I'm gonna call this file pendulum animation dot mp4. The writer is gonna be equal to ffmpeg. That's gonna give me an mp4 file, and the frames per second, that's 220. Okay, and plt.show is still there. Okay, cool. So let me see what happens when I run this file. So what I expect is an animation file called pendulum animation to happen. Okay, it's still running, which is a little bit strange, but we'll let it be. Okay, this is taking quite some time. Did it finish one? Oh, still running. Okay. Oh no, this is it. I can see it. That's strange. Why do I have the initial location of the rod still fixed? Let me check the... Okay, so looking at this animations, the few things that I need to do is I need to set the color of this line so that it doesn't change color in each frame. And I need to see why the initial location of the line is not changing. Okay, cool. So how do I fix the color of the line? I think I can just set this to be color. Let's do black, say. Okay, that should fix the color of the line. Let me also do that here. Okay, Control S, and I will blend this. Oh, I have some errors. What are they? Oh, color is not valid. Oh, I think I should do that. So color is equal to black. Okay, this way. So that's just an argument to a function. Okay, now let's run. Okay, cool. The color is fixed, but the initial line is not updating. Oh, this is what I think I should do. I should use line, and I should not have the same. I should just change the x data and the y data of the line. So this is what I'm gonna do. Set line, and I'm gonna update the object itself. Line.set x data. Okay, updating the x data of the line. That's gonna be equal to these. And then line.set y data, and that's gonna be equal to this. Oh no. Okay, let me see, is this correct syntax? Okay, cool. This is working. So I have the object line, and now I'm not replotting it. I'm just changing what it is and then plotting it. Okay, cool. I think what I need to do now is I need to also add a pendulum mass at the, representing the pendulum mass, a circle representing the pendulum mass. So I do not know how to add a circle. I'll ask ChatGPT how to draw a circle. How to draw a circle in Python. Okay, that's great. So it's these two functions, and then how do I update? How do I update the center of the circle in an animation? So basically I have a circle, I specify its center, its radius, its color, and its full, and then I want to be able to update the location of the center of the circle in an animation. So for that I'll use the function circle.center is equal to new x new y. Okay, cool. Okay, so that's to draw the circle to plot. So the origin of the circle is gonna be at the location of the mass. So here. Okay, I'm gonna make it have a radius of 0.1. We're gonna test that. Color blue, fill. Let's have it be full. So fill is equal to true. Add patch circle. Okay, great. And again, the function for updating the circle is gonna be this. So new x, which is x frame, that's the location of the center of mass, or the equation of the basically mass at the new frame, and I'll return the circle. Okay, let me double check. So circle.center, that's what it is. Okay, let me run this and see what happens. Run. So I'm able to see this animation because of plt.show, but also this animation should be saving in your specific folder. Oh wow, that's awesome. I think what I need to do is, this circle is distorted. That's because the axes are not uniform. So let's make the axes uniform. I'll ask ChatGPT how to do that. How to make axes of a plot uniform in Python. Okay, I'm using the axis object, so axis to set aspect ratio is equal. I could have also set